really still a lot of open questions about how tidal disruption events happen and unfold.
This is what black holes do, right? I like to say that they burp. Essentially, they're trying to take in so much at once that the easiest thing to do as that pressure builds up and builds up is to throw some material back out.
Most people are terrified of black holes. According to a popular belief, black holes are gigantic, bottomless pits that are invisible in deep space, yet devour everything that comes near them. However, black holes are among the most mystifying things in the universe. With a gravitational field so strong that not even light can escape its grip, black holes are probably the most interesting and bizarre objects in the universe. Due to their extreme properties, a theoretical description of these celestial bodies requires the use of general relativity, the theory proposed by Einstein in 1915, which treats gravitational fields as deformations in the fabric of space-time. Black holes are usually formed from the collapse of massive stars during their final stage of evolution. Therefore, when a black hole is born, its mass does not exceed a few dozen solar masses. However, once formed, a black hole begins absorbing the matter around it. And if it resides at the center of a galaxy, where the density of matter is high, it can grow up to millions and even billions of solar masses, becoming a supermassive black hole. What is the reality of black holes? How large can they get? Join us as we marvel at the universe's largest black holes. A black hole is a location in space that possesses so much gravity, nothing can escape its pull, even light. They're some of the oddest and most fascinating objects in space. Albert Einstein predicted the existence of black holes in 1916 with the help of his general theory of relativity, although it wasn't until 1967 that the name black hole was coined by American astronomer John Wheeler. In 2019, the first ever image of a black hole was captured by the collaboration behind the Event Horizon Telescope. While the telescope was studying the event horizon, or the region past which nothing can escape from a black hole, the EHT discovered a black hole. This can be seen in this image of black hole with the abrupt loss of photons or light particles. 3 types of black holes have been identified by astronomers. The first is stellar black holes. They are born when individual stars collapse, also known as stellar death. As stars reach the ends of their lives, most will inflate, lose mass, and then cool to form white dwarfs. But the largest of these fiery bodies, those at least 10 to 20 times as massive as our own sun, are destined to become either superdense neutron stars or so-called stellar mass black holes. These black holes are relatively small but extremely dense. The stellar black holes then absorb the dust and gas from their surrounding galaxies, which causes them to increase in size. The Milky Way galaxy contains up to 100 million stellar black holes. Another type of black hole is a supermassive black hole. Predicted by Einstein's general theory of relativity, they can have masses equal to billions of suns. These cosmic monsters likely hide at the centers of most galaxies, including the Milky Way, but there are more supermassive black holes than stellar black holes. The Milky Way hosts its own supermassive black hole at its center known as Sagittarius A. It is more than 4 million times as massive as our Sun. Scientists aren't sure how such massive black holes develop, but once formed, they acquire mass from the dust and gas around them, which is abundant in the centers of galaxies, allowing them to grow even larger. The third type of black hole is the intermediate black hole, which was discovered recently when stars in a cluster collided in a chain reaction. However, many of these intermediate black holes that exist in the same location may eventually merge in the core of a galaxy to become a supermassive black hole. No matter their starting size, black holes can grow throughout their lives, slurping gas and dust from any objects that creep too close. Anything that passes the event horizon, the point at which escape becomes impossible, is in theory destined for spaghettification, thanks to a sharp increase in the strength of gravity as you fall into the black hole. As astrophysicist Neil deGrasse Tyson once described the process, "While you're getting stretched, you're getting squeezed, extruded through the fabric of space like toothpaste through a tube." Because black holes swallow all light, astronomers can't spot them directly like they do the many glittery cosmic objects in the sky. As gas and particles are pulled into the black holes, radiation is generated. An international team of academics and scientists set out to acquire the first image of a black hole, Focusing on Sagittarius A, the supermassive black hole that is at the center of our Milky Way galaxy. The image of Sagittarius A was quite challenging to acquire, necessitating the collaboration of several observatories and radio telescopes all around the world. This global network of radio telescopes was known as the Event Horizon Telescope, and the procedure of capturing a single image of Sagittarius A was quite spectacular. From observatories in French Alps to another in Spain and all the way to MIT, a network of 10 observatories worked together concurrently. The antennas from these observatories required to be synced down to the millisecond, thus atomic clocks were set at each station to begin the procedure at the same time. After settling at the antenna, astronomers targeted the Event Horizon Telescope and Sagittarius A, which are approximately 27,000 light-years distant from Earth, cutting through a sea of stars, planets, and cosmic dust. The collected data was integrated and processed using advanced mathematical methods to reproduce the captured image. The image was reconstructed, which depicted Sagittarius A's very first vision, which took the appearance of a blazing donut-shaped ring of light. This ring image was not of the black hole itself, but rather the outline of light outside the event horizon, which is just beyond the barrier where light cannot escape the supermassive black hole's gravity. The dazzling yellow ring that surrounds the black hole is a white-hot plasma with a temperature of more than 18 billion degrees Fahrenheit. Scientists were also able to establish that the supermassive black hole was approximately 4 million solar masses. Now, astronomers have recently published a major finding about a black hole that has been burping out energy from a small star. It was observed shredding in 2018, and after 2 years, it didn't eject any such material. How unusual is this? Super unusual. Yvette Sens, an astronomer at the Center for Astrophysics and lead author of the paper, tells NPR. We've never really seen this before to this degree. Researchers made the discovery when they used a powerful radio telescope facility, the Very Large Array in New Mexico, to check in on some 24 black holes where stars had been shredded after coming too close to them. That is, the material in the star was pulled apart, or spaghettified. Such events are also called tidal disruption events, or TDs. What they found was that one of the TDs, the one named at 2018 HYZ, if you're curious, was emitting energy at an unusual velocity and at a very surprising time, more than 2 years after the event. This behavior is different from what was observed in black holes before, in 2 ways. First, the timing, as it is more common to see radio emissions from black holes within the first few months after swallowing a star. And second, the energy being emitted in this case doesn't quite fit with what astronomers have seen before. The results, amazing as they are, were published this week in the Astrophysical Journal. The main goal of the study is to help scientists better understand how black holes feed, which Yvette Sens compares to burping after a meal. To put it into perspective, TDs usually spit out this material at about 10% the speed of light. The study's co-author Ed Oberger, an astronomy professor at Harvard University, said in the statement, "This is the first time that we have witnessed such a long delay between the feeding and the outflow." Astronomers were looking for signs of TDs over the past few years when they spotted this event. The data they collected with the Very Large Array in New Mexico showed that this black hole had mysteriously come back to life in June 2021. These findings stimulated them to analyze at 2018 HYZ further. Situated in a galaxy 665 million light-years from Earth, in October 2018, a black hole, 20 million times more massive than our Sun, was observed devouring a star that had ventured a little too close to it. Astronomers often see these violent encounters between stars and hungry black holes. The event itself wasn't a surprise to them. This mind-blowing scenario is one of a kind and has never been documented previously or never really been understood. Why is it vomiting out materials that it consumed years ago? And could this mean that we never really understood black holes in the first place? When this spaghettified material falls onto the black hole, it heats up and creates a flash of light that astronomers can see from millions of light-years away. Sometimes the black hole will spit some stellar material back out into space. Let's just say, black holes are pretty messy eaters. Sens mentions, "We applied for director's discretionary time on multiple telescopes, which is when you find something so unexpected, you can't wait for the normal cycle of telescope proposals to observe it. All the applications were immediately accepted. For Sens, the discovery is what she and her fellow astronomers hoped to find, something big. She told that she wanted to be an astronomer since she was 13 years old, making this discovery the excitement of a lifetime for her. How supermassive black holes like this one, that are millions to billions of times more massive than our Sun, take shape is even more incomprehensible. Many scientists consider that these giants are at the center of most galaxies. New Hubble Space Telescope observations have helped to support the theory that supermassive black holes start out in the dusty centers of starburst galaxies, where new stars are made quickly, but scientists are still figuring it out. Let us know what you think of black holes in the comments box down below. As always, thanks for watching our video. See you in the next one.